Hi all, welcome to this talk, The Tipping Point of Enterprise AI Product. My name is Mayukh Bhaowal and I manage the Einstein platform product at Salesforce. Before we get going, a few words about Salesforce, Einstein, and why you should listen to me. Salesforce is a CRM or a customer relationship management company. And thanks to our customers and partners, we have been number one in this space for probably more than a decade now. And if you're wondering what has kept us ahead of the pack, look no further than this tweet. It's because of our investment and success in AI. And AI in enterprise, in a nutshell, is Einstein. Today, with Einstein, we are making around 11 billion machine learning predictions per day. Now, I would confess, that's a little bit of a vanity metric. So here are some real customers with real business KPIs. In the commerce space, we have Stonewall Kitchen with a 22.5% increase in their website revenue using Einstein. In the marketing space, we have Room and Board with a 150% increase in their conversion rate. And OnCall are looking at a 2x lift in their mobile adoption. Also, being part of the platform, I have this leverage and unique opportunity to look at enterprise AI adoption across a wide variety of domains, such as sales, service, marketing, commerce, and so on and so forth. It gives me an aggregated perspective of the challenges of AI adoption in the enterprise space. Now, all of these sounds like a great customer momentum, but here is a secret. It represents the phase one of enterprise AI adoption. I call it the S-curve of AI adoption phase one. And the leaders and visionaries in the industry are in this unique position where they are transitioning the S-curve of phase one to the AI adoption phase two S-curve. We are therefore at a tipping point of enterprise AI product. In this talk, I'm going to share some of my learnings about the challenges and hurdles that we faced while transitioning from phase one to phase two, which is more mainstream, and some of the mitigation strategies that has worked well. First, a big aha moment for me was enterprise AI products can be sliced into two dimensions. On the y-axis, you have the dimension of AI nativeness, the AI add-on versus AI native product. On the x-axis, you have setup complexity, high setup versus low setup. Let's use some concrete example at Salesforce Einstein to explain each of this dimension. We'll start off with the top right domain of AI add-on but a low setup product. Example is Einstein Marketing Engagement Scoring. Now, some of you who are familiar with the marketing domain must realize an example of a marketing software is a campaign builder, a marketing campaign builder. Here is an example at Salesforce. This is an email marketing campaign. The campaign starts. The marketer is waiting for a couple of days. And then if the users don't open the email, they send them a Facebook ad campaign. If they do open an email, they send them a second touch email. It's pretty simple. With engagement scoring, we are introducing predictive capabilities, such as Einstein Split. What it does is, instead of waiting for those 2 days, you can use Einstein to predict the likelihood of the users to open an email. Now, this is augmenting the currently existing campaign builder. If you take the AI away from the product continues to exist. So therefore, it's an AI add-on product. And second, the engagement scoring requires almost minimal setup. It's out-of-the-box turnkey feature. So that's an example of an AI add-on and a low setup product. On the top left quadrant, we have AI native and high setup. Example is Einstein Bot. This is basically a chatbot application. Imagine that you're in a retail space, and post-purchase, your customers have a bunch of frequently asked questions, such as where is my order? When is it going to arrive? What is the return policy? This is a great opportunity to leverage chatbot to address those frequently asked questions. Now, funny enough, you have the word bot in the name of the product, so it's apparently inherently driven by AI. So if you take AI away from chatbots, it ceases to exist. You basically have to staff up a customer support center to address those same questions. Secondly, there is also a lot of setup involved because you have to set up the dialog flow. Also, based upon the use case, you might have to train unique intents. In the retail space, the intents can be return or order delivery, whereas in the healthcare space, for example, it can be about insurance. So it's an example of native yet high setup product. Another example is Einstein Recommendation Builder. It's a recommendation engine in the enterprise space for addressing custom long-tail recommendation use cases. Very similar to recommendation engines you see in the consumer space, like product recommendation or movie recommendation, but for long-tail use cases. For example, let's say you're an HR company and you want to recommend jobs to candidates. Maybe you're in a financial industry, you want to recommend financial products to your customers. Or maybe you're in the entertainment space, you want to recommend events to your users. These are all example use cases. Now, Einstein Recommendation Builder allows you to recommend any object or entity A to any entity B based upon prior historical records. And recommendation engines are inherently personalization engines, which requires or uses AI. If you take AI away from it, it's no longer is a recommendation engine. So it's again an AI native product. Secondly, specifically in the enterprise space, this requires a lot of setup. You have to set up for each use case who your users are, who the items to be recommended is, and where are the past interactions or history lies. Additionally, you might also have to do several kind of segmentation around the users and items. Again, an example of an AI native and high setup product. Finally, on the top right, you have AI native but low setup. Examples are Einstein Search, which is basically enterprise search, and Einstein Translation, which is a machine translation product. So the key takeaway here is, as you transition those S-curves, the low setup product generally tends to get faster and quicker adoption. And the AI add-on products also tends to get faster adoption because, and I'll talk about this a little bit later, you're not drastically changing the user's workflow, you're augmenting that. Having said that, AI native products, though slower to get adoption, creates a much more bigger defensible mode and bigger differentiation of your product over the long run. So there are trade-offs. And we'll talk more about these challenges and hurdles as we go further in this talk. So here are the 4 key hurdles that we have seen in implementing and adopting enterprise AI products, namely data, setup, trust, and change. Let's talk about the data challenge first. And the 2 key questions that we need to address here are, do I have equitable training data? Now, machine learning algorithms, of course, requires a lot of data, especially those gas-guzzling deep learning algorithms. And as you move to mainstream, long-tail enterprise use cases, you won't have that much of labeled data. So the question is, how do you address small data issues? The second challenge or question that we need to address is if the data is clean and accurate. So let's talk about the equitable training data angle, and 3 methods that I have seen in my experience address these challenges well. These are labeling, data augmentation, and global models. The first strategy is about investing in an internal labeling tool. Here's an example of a labeling tool we are using in Einstein to label voice data and getting chat transcripts or voice transcripts out of the voice data for voice applications or ASR, speech recognition applications. There are a couple of key things I want to call out while we were building this labeling tool. First, privacy of the data. Because this is enterprise space and customers are really careful about the data and where the data is going, we could not just send this data externally and crowdsource the labeling aspect. We had to build a team internally to be able to keep the data private and secure, and also implement strict audit control about who has access to the data and who is labeling it when. The second challenge or takeaway here is GDPR. If you get an upstream GDPR signal to delete the data, we need to make sure that we maintain the lineage of that raw data to the labeled data to be able to detect and delete the labeled data as well. The next strategy to address small data issues is data augmentation. This works pretty well with unstructured data, for example, in image or vision use cases. Here's an example of a vision use case at Einstein in consumer packaged goods space. So the idea here is you're going to a grocery aisle, taking a snapshot or a picture, and you want to use that picture to do planogram, which means inventory count and also shelf spaces of different products. The core idea here is taking an image, which is there on the left here saying, taking an image and introduce noise in it, like rotate it or skew it to explode the number of training labeled images. And on the right, you see its application to the cereal box. And this is a great technique to increase the number of labeled images and increase the performance of machine learning algorithms, especially when your customers don't have a lot of labeled data. The final strategy to address small data is global models. Now, currently in Einstein, majority of our deep machine learning and deep learning models are customer specific. What do I mean by that? Each customer uses its own data to build its own model. So Appian will have its own data and own model. US Bank will have its own. There's no mixing or commingling of data. Now, this is very important because these customers cares a lot about their privacy. But what about those smaller customers who don't have enough data? This is where we started experimenting with this concept of global models, which means now we mix data from multiple customers, multiple organizations to create one global model. Of course, we have to be very careful and make sure that customers are okay with it and they opt in, or we provide them an option to opt out. This is a great way, a collaborative way through which even smaller customers can leverage each other and compete with other data-rich organizations. Wrapping up, the dimension of data is data cleanliness and accuracy. In fact, there was a survey done, and one of the top barriers of adopting enterprise AI product was dirty data. So in Einstein, in our automated machine learning, we invested a lot in data cleansing and feature selection. We use statistical methods such as Pearson correlation or chi-square to figure out the association of the raw features with the target label. Sometimes that is very low, which means these data inputs are really noisy and should be probably thrown away. And in some cases, their association is really high, which points to data leakage or label leakage, and such features needs to be dropped. We would also look at drift, for instance, between the training data and the scoring data, and thereby either remove those features which are causing the drift or retrain the machine learning algorithm. So the key takeaway is investing a lot in data cleanliness and not just assuming that if you dump it into a deep learning algorithm, a magic will happen on the other side. So that's all about data. Next, I want to talk about setup. And the key questions here to address are, does my machine learning setup support rapid iteration? As product managers, you all have seen this image, how not to build or how to build a minimum viable product. What I've seen in my experience, the same thing applies for administrators and implementers who are implementing an AI product in the enterprise space. Not to do it in one go, but do it iteratively. And the second question is, are there templates for common setup configurations? Let's dive into each of these a little bit more. We'll talk about the rapid iteration support in setup first. And the use case is the same as recommendation builder. If you remember, a quick recap, this is for custom AI-powered recommendations in the enterprise space where you want to recommend any entity A to any entity B. And so we have a three-step iterative setup. Step one is a very, very simple initial setup. It asks, I want to recommend this to this, and my history or recommendation history lies here. Simple. 3 fields, that's it. The administrator or the implementer will then sit back, and this leads us to step 2, and we will do all the machine learning hard work behind the scenes and surface some results, such as recommendation quality, top predictors. This does 2 things. First, it immediately rewards the implementer or administrator with some results, so they can see some tangible result of their hard work. Second, it reduces cognitive load by splitting up the setup in many smaller pieces, thus reducing setup abandonment. So once we see the results, we introduce a step 3, where the admin can now further fine-tune recommendations. They can add filters to users and items. They can do segmentations of users and items. And then again, see the results and iterate, so on and so forth. The second way to address setup challenges, which we have seen work very, very well, is introducing templates for common configurations. So for recommendation builder, we have these common setups that we have seen, or common recommendation patterns, like recommending products to existing customers, or parts to orders, or jobs to candidates. When the user selects any of these templates, what happens behind the scene is we introduce smart defaults in many of these setups, thus reducing the setup complexity considerably. The same thing has worked really well with the chatbot setup as well. So that was data and setup. The next, I want to talk about a very crucial topic, which is trust. And the key questions to address there are, am I providing model transparency to my users? Am I proving ROI with my users? And finally, are we addressing compliance and governance? Let's address the transparency angle first. If you remember the recommendation use case and the scorecard or the results page, we show a recommendation quality gauge, which is a CTR metric. We also show some kind of a global interpretability or explainability where we surface the top predictors. For instance, order type ID being direct sales seems like a top predictor. Product type being a general inventory item in this example is also a top factor. Now, this helps confirm the user's confirmation bias. Generally, we have seen our customers who understands their business very well have a good hunch of the predictive factors in their business. And when we surface the same predictive factors to the users as a part of the setup process, it confirms to them that the machine learning algorithm does really know what they know, and hence they start trusting the machine learning model. Beyond transparency, we also have to prove ROI to our users to get adoption. I want to pause here and see this is very, very critical, especially for cool AI technology. They're looking to see what is their cost and what is the return on the investment they're getting using these AI products. And there are three strategies that I've seen work really well for us: leftover baseline, A/B testing, and mapping the business KPI to the machine learning metric. Let's talk about leftover baseline. With every machine learning metric, what we have seen, we need to provide some kind of a lift or comparison to a baseline metric. For recommendations, that baseline is a popularity model, basically pure statistics. Count the most popular items. If you recommend them, what kind of a lift you get when you use a proper AI-driven, personalized approach. Now, this is a true story. I was talking to this customer who were recommending parts to orders. And initially, the recommendation quality for them was around 60%, a 60% CTR. And the customer was not happy with that result. And then I kind of pushed back and said, we actually looked at your data and we did some pre-calculations, and we found that if we didn't use an AI-powered recommendation, but we used a popularity-based approach, we are seeing a CTR of around 20%. So by using recommendations, you're seeing a lift of around 300%. Now, believe it or not, but this is true, the tone of the customer immediately changed. Another way you can prove leftover baseline is predicted versus actual dashboard or metric. This is a use case of customer cases and which of those are going to cause escalation, basically a binary classification problem. This bar on the left shows the number of cases which in reality did not cause escalation. And this blue shaded region, which I've circled, are the one which the machine learning algorithm predicted to cause escalation. So it's basically the false positive. Same for the next bar, which is the number of cases in reality which did cause escalation, but the machine learning algorithm predicted as no. Now, this is a huge way to prove that your AI approach is working. What did the machine learning predict and what happened in reality? But the true golden method of proving ROI is actually twofold. One, mapping the business metric, which the users really care about, to the machine learning metric. So here you see an ROI dashboard. Here there is a model performance and model accuracy, which is a machine learning metric, something which business users don't really care about, they don't really understand. It's not very meaningful. But side by side, we are showing an associated business KPI, such as year-over-year churn rate for a churn prediction application, or percentage of late invoices for an AP or AR application. And this helps direct comparison with the business KPI with the machine learning metric. Additionally, showing A/B results can help prove ROI tremendously. Let the machine learning method launch to a segment A of your customers or users, and hold back a segment, like a control segment, where you don't use the machine learning method, and show them the difference of what advantage or what benefit the machine learning method is bringing compared to a non-machine learning method. Wrapping up the trust bucket is addressing compliance and governance. Now, this might sound a little bit boring and mundane, but as we cross those S-curves and go mainstream, some of the compliance measures becomes table stakes, such as ISO and SOC certification for financial applications, HIPAA compliance for healthcare applications. If we do not invest in these, we would lose again and again to other competitors in the space who has got themselves certified and compliant. Another important aspect is we need to show governance. This is very, very relevant in today's world with the coronavirus pandemic, where suddenly all of our scoring data drifted so much farther away from the training data because of the global changes. So we need to have an automated way to detect such drifts and alert the users, and also automatically retrain the machine learning model when we see such drift between training and scoring data. The fact that we have invested and we can showcase such governance also helps build trust with the machine learning product to your end users, especially these mainstream big customers. The final topic or the hurdle, potentially one of the most debatable, trickier and harder one, is about change. And some of the key questions here are, how do we renegotiate the deal between the people and the machine? Am I drastically changing an existing workflow? And finally, is the new business of AI same as that of the old? Now, what we have learned is if we have to get more and more adoption of these AI products, we need to circumvent the fear of AI taking away jobs from the very same users and customers who we are reaching out and trying to sell this product. There is a whole spectrum of this human-machine interaction. On one end, it's completely manual. On the other end, it can be fully automated. However, in order to get true adoption, we need to hit the right balance between complete manual and fully automated, which means being very crisp and clear, almost pedantic about what humans should continue doing, hopefully the more intellectual tasks, and what they should stop doing, like the more mundane and tedious ones. As an example, I was talking to the TED translation team, the TED Talk translation team, and their problem is very interesting. So they have these famous TED Talks, and they have around 7 days to be able to translate those captions into 5 or 6 global languages to make those talks go viral. If they miss that window, they miss the window of virality. And initially, they were very, very skeptical using machine translation because they thought, the translators thought it's going to take away their job. But finally, they got sold. Machine translation is being used for the raw word-to-word translation. And after that, it goes to the human translators who edits the translation to reflect the true sentiment, emotion, and purpose in the speaker's presentation and delivery. Not only did they end up keeping their job, but they were actually much more happier doing this more higher level intellectual task than doing word by word, boring, mundane translation. It's a great example of how you renegotiate the deal between the people and the machine. The next question to address is, are we drastically changing an existing workflow? If you recollect, I talked about this marketing campaign builder product where we're introducing AI as an augmented predictive capability. The marketers continue to do what they know and have learned to do, build campaigns, but we merely make them more productive and effective by introducing new dimensions and segments through which they can create a decision engine. And the final thing to talk about is the new business of AI is same as old. Now in this Venn diagram on the left, we have pure software services, which has great unique economics. And on the right, we have services business, which have poor unit economics. What I've come to realize over the last 3 to 4 years are the scaling challenges in enterprise AI product, because enterprise AI really lives in long tail. Your customers are of different shapes and sizes. The use cases are so custom, which means more and more of customers who don't know anything about AI and machine learning need help defining their machine learning problems, the AI problems. They need help defining their KPIs. and they also need help mapping them to the machine learning metric. So at Einstein, we have these teams like our outbound PM team, our emerging tech evangelist team, which provides the services aspect of the business. It works with customers, helps them to understand the problem, and suggests the right machine learning tool for their problems. Now, this might sound counterintuitive, but I do see this mix of software and services work for enterprise AI products for quite a while. Of course, with the period of time, the software bubble might expand and the services might shrink, but I predict for the foreseeable future, they need to work together in great harmony for greater adoption. With this, I want to end with the key theme and message of this talk. As we move up the stage of AI development from cool marketing demos to pilots to GA products and provide more and more value to our customers, we are facing this chasm of data, setup, trust, and change against adoption, mainstream adoption of such AI products. In the industry, we are in this very interesting tipping point where we are in the process of transitioning or overcoming this chasm, which would introduce and usher an era of true commodity enterprise AI products. And with that, thank you so much for joining my talk. If you have any further questions, feel free to reach out to me. Thank you so much.